So this is pages 3 and 4 on the final review for secondary math 2. I'm going to go through a couple problems, starting with page 3. Number 1, it's asking us to find the degree. So we always look at the highest degree, and so this one, the highest degree is degree 3, so that's simply our answer. We don't even need to name it using the name. We just want to know what's the degree. It's degree 3. This one, don't call it degree 1. There's not a degree 1. If there was degree 1, there'd be an x. So if it was degree 1, it would be x to the first. But really, technically, we have x to the 0, because really we don't have that x there. So this would be degree 0. This one would be degree 5. When you multiply, you add your exponents. Now, even though p and q are not the same base, this still, because they're being multiplied, counts as degree 5. And then same thing here. Even though we can't combine 6 and 3, they're being multiplied. So this would be considered degree 9. Now if we had something like this, for example, if we had 7x to the 5th minus x, y, x cubed y to the 7th, then our highest degree, we would only add up the pieces that are being multiplied. So the highest degree would be, in fact, 7, 8, 9, 10. So in this example, our highest degree would have been 10. So I just made that up. You go off the highest degree, which 10 is greater than 5, and you don't add those up because they're being added. So anyways, hopefully you understand the difference between multiplication and addition. Okay, we're asked to simplify. Make sure you don't distribute if you're not multiplying. We're adding this polynomial to this polynomial. So all you're doing is combining like terms. 7t squareds plus 6t squareds is 13t squareds, and then 9 plus 8 is 17. In this one, we're going to combine like terms. We're not multiplying these same things, so we don't add our exponents. We're not dividing these things, so we don't subtract our exponents. We're simply combining like terms. So 5x cubed y squared minus 7x cubed y squared is negative 2x cubed y squared. So once again, the apple part doesn't change when you're combining like terms. So we are adding these two like things together, and the apple part doesn't change. So because we were adding these, we're just combining like terms, so our final answer is negative 2x cubed y squared. Simplify. Once again, with same thing here, we're multiplying these two polynomials. So I have j squared minus 4j plus 3j, and then minus 12, combine like terms, j squared minus 1j, and then minus 12. So I'm not going to write that 1 there. J squared minus j minus 12. All right, let's distribute on this one because we're multiplying. So we'll have 3x squared, and then minus 18x, minus 1x, and then plus 6. Very careful when distributing negatives. So 3x squared minus 19x plus 6, and that would be our final answer on that one. All right, careful here. We have to rewrite this one as 2z minus 3 times 2z minus 3, and then yes, we're going to distribute. So we have 4z squared minus 6z minus 6z, and then plus 3 and plus 9, and then be very careful because a lot of people assume the middle term cancels out, but that adds up to be negative 12z's. So don't just cancel it out because they kind of look the same, and we're done here. All right, so we're given on 17 the length is equal to x plus 9, the width is equal to 2x minus 1. What's the area? Well, it's of a rectangle, so we know area is equal to length times width. So you're literally plugging it in. X plus 9, which is the length, times the width, which is 2x minus 1. Now we would distribute, so we have 2x squared minus x plus 18x, and then minus 9, combine like terms. So 2x squared plus 17x is minus 9, and that is the area. So area is equal to that. All right, so if we want to build a trinomial with the greatest common factor of 3x, we start out by saying, okay, so a trinomial has 3 terms, and it's separated by plus or minus signs. So I'm just going to go with plus signs, because we get to create our own trinomial. So we have our 3 terms thing here, and we want the greatest common factor to be 3x. So you can do many different things. I'm personally just going to go with something as basic as, okay, So I'm going to say this one has a 3 and an x cubed. Let's see, cubed. That will work. This one will have a 3x squared. And this one will have a 3x. So now the greatest thing in common in all terms is 3x. So if I pulled out 3x, left would be x squared plus x plus 1. So notice nothing more came out. So that was truly our greatest common factor. There are other trinomials you could come up with as long as the greatest common factor is 3x. So the greatest thing you can pull out of all three terms needs to be 3x. This is just the one I came up with, and you could do many other things. Okay, so now we're on to page 4. On page 4, we're asked to factor this. The first thing we look for is there anything in common in all three terms? There's not, so we move on. Well, this is a quadratic, so we always do what multiplies to be a times c. So a is equal to 1, b is equal to 11, and c is equal to 24. Well, multiplies to be 24 and adds up to be 11. So I started listing out factors of 24, and I got 8 times 3. Those could add up to be 11. Look, 8 plus 3 does equal 11. So it works in both cases. So then from there, I knew that since my a value is 1, see, look, my a value is 1, I can quick factor. So my factors were right here, positive 8 and positive 3. So I know it's going to factor to be a binomial with those two things, positive 8, positive 3. Now, if you wanted to drop and break on that, you would be fine. You'd get the same answer. So just go through that. If you like it the long way, that's fine. So looking at this one, same thing. Is there anything in common in all three terms that we can factor out? The answer is no. So then I look, is it quadratic? Yes. So I'm doing what multiplies to be, well, a is 1, b is negative 7, c is 12. So what multiplies to be a times c, what multiplies to be 12 and adds up to be negative 7. So I did 4 times 3. They both have to be negative. And that works because negative 4 times negative 3 is positive 12. Negative 4 plus negative 3 is equal to negative 7. So it worked in both cases. Now once again, since our a value is 1, we can quick factor it. So it's going to factor to be a binomial multiplied with those two factors in it. So it's going to have an s, and then we're going to have a minus 4, and we're going to have a minus 3. So minus 3. And we're done. You could do the long way, drop and break. You should come up with the same answer. Okay, looking at number 3 here, we have what multiplies. So first of all, we always check, is there anything in common we can pull out in the beginning? The answer is no on this one. So we always look, well, is it quadratic? And look, it is. It's degree 2. So we do what multiplies to be a times c, so 2 times 70. So what multiplies to be 140 and adds up to be 27. And those factors, if you didn't know, you'd start dividing them in your calculator. 140 divided by 2, 140 divided by 3, 140 divided by 4. You'd list them all out. And as I went through this, I found 7 times 20. Well, so 7 times 20 is 140, and then 7 plus 20 is 27. So our factors are 7 and 20. Now with this one, we cannot quick factor because our a value right there is not a 1. So we've got to drop and break. So 2m squared. And we drop down positive 70, and then you're breaking down your middle term, you're rewriting it as these two factors, but with the variable n. So it'll be plus 7n plus 20n. That's one way of doing it. So then I factor by, I throw parentheses around by grouping, and then we look at this group, what's in common. The greatest thing is an m, so left is divide everything by what you pulled out. Left is 2m plus 7. The greatest thing in common here is a positive 10. Divide each thing by what you pulled out. So then left is 2m plus 7. Now look, our safe haven's exactly the same, so we've done it right. We pull out 2m plus 7. When we pulled it out, it divided out. Left was m plus 10. So we factored this. You would check to make sure it's factored completely. Nothing more comes out of 2m plus 7. Nothing more comes out of m plus 10. All right, looking at this group, is there anything in common in the beginning we can pull out? No. Then we look, it's quadratic, so then we'll go ahead and do the same thing. We'll multiply to be a times c, so that would be 60, and adds up to be negative 16. And I know this one right off. 6 times 10 And they both have to be negative because it needs to add up to be negative 16. But check, does it work in both cases? Negative 6 times negative 10 is positive 60. And negative 6 plus negative 10 is negative 16. Once again, because that a value is not a 1, we cannot quick factor, so we've got to drop and break. We drop down our n terms, 4z squared, drop down positive 15, and then you're breaking down the middle term, you're rewriting negative 16z as these two things, but with a variable. So negative 6z, and then minus 10z. You throw parentheses around the first two, around the second two, including the sign, factor out of each group the greatest thing in common. In this group, the greatest thing in common is a 2 and a z, so I divide each thing by 2z. So left is 2z minus 3. And then in this one, the greatest thing in common is a 5, and because there's a negative in front, I pull out negative 5, divide each thing by what you pulled out. So then we would have 2z minus 3. Check your safe haven, so we've done this correctly. 2z minus 3, you pull it out, therefore it divided out, left was 2z minus 5. And then you check and make sure it doesn't factor out any further. 2z minus 3 doesn't factor out any further, and neither does that. Okay, once again, always check, is there something in common in the beginning? Nope. So once again, it's quadratic, so we do what multiplies to be a times c and adds up to be b. So negative 21 times 8 is negative 168, and what adds up to be negative 22. So factors. I just started testing things. 168 divided by 2, 168 divided by 3, divided by 4, divided by 5, divided by 6. And I got 6 and 28. Now those could add up to be negative 22 as long as my negative is with 28. Check it in both cases. Is positive 6 times negative 28 negative 168? Yes. And then positive 6 plus negative 28 is truly negative 22. So it works in both cases. Once again, because our a value is not a 1, we can't quick factor, so we're going to go ahead and drop and break. So we drop down our n terms, 8y squared, and negative 21, and then we break down our middle term, rewriting it as these two factors. So I'm going to just put, order doesn't matter, but I'm just going to randomly go with, I'm going to put the 6 first, so it was positive 6 y's, these are y's, so positive 6 y's, and then negative 28 y's. And then we put parentheses around the first two, around the second two, pull out the greatest common factor in each group. So I'm going to pull out a 2 and a y, divide each thing by what you pulled out. So left is 4y plus 3. In this group, the greatest thing in common is a negative 7. I pull out negative due to the negative in front, so divide each thing by negative 7, and left is 4y plus 3. Check your safe haven. Yep, we're doing this right. So we pull out 4y plus 3, so then it divided out, left us with 2y minus 7. And that does not factor any further. There we go. And then number 6, kind of same thing here. There's nothing in common in the beginning that could factor out. So I do what multiplies to be a times c. So 576 and adds up to be b, positive 48. So I listed out a bunch of factors. This one took quite a while. But I kept going, testing things, and I got up to 24 and 24. And then look, positive 24 times positive 24 is 576, and then 24 plus 24 is positive 48. Now, once again, because our a value is not a 1, we have to drop and break. So we have 9x squared. We have positive 64s. Breaking down that 48x as positive 24x, and then positive 24x. Positive 24x. And then you group the first two, and group the second two, factor out of each group the greatest thing in common. This one has a 3x in common, divide by what you pulled out. So left is 3x plus 8. And then in this group, the greatest thing in common is an 8, so I pull it out, a positive 8, divide each thing by what you pulled out. So left is 3x plus 8. Our safe haven's good, so we'll factor it out, 3x plus 8. So so it divided out. Left us with 3x plus 8. So you could write it like this, or you could say, I know that technically that's 3x plus 8 squared. Either answer, I guess, I'll accept. Okay, number 7. Is there anything in common in the beginning we can pull out? No. So we're doing, well, it's quadratic, so we're doing what multiplies to be a times c. Remember, a in this one's 1, b in this one's 0, c is negative 64. So what multiplies to be negative 64 and adds up to be 0. 8 times 8. One of them has to be negative. And then it works in both cases. And then our a value is a 1, so we can quick factor. So it's going to factor to be a binomial multiplied by a binomial. And inside is going to be a g, and then a g, and then a negative 8 and positive 8. So negative 8, positive 8. If you were to drop and break, you'd get the same answer as long as you did your drop and break correctly. So same thing here. Is there anything in common we can pull out in the beginning? The answer is no. So then we do what multiplies to be a times c. So it multiplies to be negative 100 and adds up to be 0. 10 times 10, one of them has to be negative, negative 10 plus 10. So our factors are negative 10, positive 10. Because our a value is not 1, we have to drop and break. So we drop down 4s squared. We drop down negative 25. And our b value that was missing in here, we break down. So drop and break and write it as these two factors. So negative 10s and positive 10s. Then you throw parentheses around the first two, around the second two. In this group, the greatest thing in common is 2s. So left is 2s minus 5. The greatest thing in common in here is a positive 5. So then left is 2s minus 5. Now our safe haven's good. So we pull out 2s minus 5. Thus it divides out, leaving us with 2s plus 5. So 2s plus 5. Okay, number 10, we're simply asked to factor. Is there anything in common in all 4 terms? No, but there's 4 terms there. Well, it's not quadratic, so you don't say what multiplies to be a times c. But once again, there's 4 terms. We always try factoring by grouping if there's 4 terms. So the greatest common factor here would be a 3r squared. Divide each thing by what you pulled out. So then left is 2r plus 5. And then the greatest thing in common here is a positive 4. Divide by what you pulled out. So then we'll have 2r plus 5. Check your safe haven. Safe haven's good. Pull it out. 2r plus 5. We just factored that out, so it divided out, leaving us with 3r squared plus 4. And that would be our answer for that. Continuing here, we're almost done here. Once again, there's nothing in common in all 4 terms, so we'll try factoring. Because there's 4 terms, factor by grouping. In this group, the greatest thing in common is a 2c squared. Divide by 2c squared from both terms. Left is 5c minus 6. And the greatest thing in common here looks like is a positive 3. So then divide each thing by what you pulled out. So left is 5c minus 6. Our safe haven's good. Pull it out. 5c minus 6 divides out. Left is 2c squared plus 3. And we are right there. Okay, number 13. We're given the area is equal to t squared minus 4t minus 45. We're given the length is t plus 5. What's the width? So we know area is equal to length times width. So we know t squared minus 4t minus 45 is equal to the length times by the width, which the width is t plus 5. So we're like thinking, well, what could we multiply by to get this t plus 5 to be equal to this? Length times width. Well, if we take this piece and factor it, we'll have 2 things being multiplied together that equal it. So that's what I'm going to do. I'm going to factor. It's quadratic, so I do what multiplies to be a times c, which is negative 45, and adds up to be b, which is negative 4. 9 times 5, it needs to be negative 4, so the negative must be with the 9. because our a value is 1, we can quick factor this. So this factors to be a binomial with those two things, a t minus 9 plus 5. So look, t minus 9 times t plus 5 is equal to this. This is just the factored form of it. So if our length, our width, this is width, sorry. So our length is this, so what's our width? Well, it must be t minus 9. So our width is t minus 9. So all we have to do is factor that one. Okay, we're given number 16. We're given the volume, and we're asked to find the dimensions, and it's a volume of a rectangular prism. So volume is equal to length times width times height. So once again, we're given this volume. Isn't it if we factor it? Wait, let's see. Did I write down 16 right? On page 4. Nope, I didn't write down the right answer. I mean the right problem. Just a second. I'm going to start back. We're on 16, but I'm going to fix the problem. Okay, so this is our volume. So we need to know what 3 things multiply to be this. And we know that the opposite of multiplication is factoring. So this is already all multiplied together, all like terms are combined, so we're going to go backwards. We're going to factor. So we're going to look for the greatest thing in common in all 3 terms in the beginning, and that's a 2 and an x. So I'm going to write what's left inside. I've divided out of 2x, I factored out of 2x, the greatest common factor. So then left is 2x squared plus 15x, and then plus 18. So then I'm like, okay, so we know the length, the width, or the height. One of our factors is that. But we need 2 more factors. Well, we know this piece might factor further. It's quadratic, and we know how to factor a quadratic. 2 times 18. Well, multiplies to be a times c. So it multiplies to be 36 and adds up to be 15. So that would be 12 times 3. And then 12 plus 3. We cannot quick factor because our a value is not a 1. So we're going to drop and break. So we have 2x squared, and we drop down 18. We have positive 18. And we break down the middle term, rewriting it as these 2 factors. So positive 12x and then plus 3x. And then I'm going to ignore this 2x for a minute, but it'll be in our final answer. But I'm ignoring it for a minute. So I continue, group these 2, group these 2. In this group, the greatest thing in common is 2x. Left is x plus 6. Greatest thing in common is a 3. Left is x plus 6. Factor out our safe haven of x plus 6. And then left was 2x plus 3. So that piece factored to be that. And then we also had our 2x. So now look, isn't this the length times the width times the height? That equaled the volume. Yes. So we just found the linear dimensions. Now the reason they're linear is because they're all degree 1. So that's just helpful, just a little side note. The reason they're linear dimensions is because they're all degree 1. And that is the end of the video for pages 3 and 4. I didn't do every single problem, but I really feel like with the help of this video, you should be able to finish that up correctly. Thank you for watching.